Hi and welcome to challenge number 13, reverse array. In this challenge, our task is to reverse the order of elements inside of an array in place. So if we have an input array like this, where we have 1, 2, 3, 4, 5, if we reverse it, the output should look like this, 5, 4, 3, 2, 1. Let's jump into JavaScript. That's going to be the first language in which we're going to tackle this. I'm going to create a function, and I could call it array or reverse array. This is going to accept an array. And what is it that we actually want to do? Well, we want to reverse an array. Do we have some sort of a built-in method in JavaScript that's going to do it for us? Yes, we do. It's the reverse method. So I'm going to grab our input array and I'm going to call on it this reverse method. And the result of this, I'm going to store it inside of a variable and I'm going to call it result. There we go. And then the only thing that this function is going to do, it's going to return that result. And that's it. That is the solution. So I have created a few test cases. I don't want to type them out because at this point it's just a waste of your time. Our very first, however, I'm going to go over these, but I seem to have changed the name of my function. Whoops. Let me just copy that, put it right there. There we go. So the first test case is just our input and output array. The second one is an empty array. So if user passes an empty array, we need to produce an empty array. If we have one item, if we reverse it or not, doesn't really make sense. If we have strings like first and second, the output should be second and first right here. And then we have again numbers, but these numbers, they have some duplicates. So this is an array with duplicates. We have 1, 2, 2, 3, 2, 1. And then we have 1, 2, 3, 2, 2, 1. So if you just reverse that. And then if we have a mixed array, this is going to be the result. So all of these test cases, all 6 of them are going to be the same test cases for all 5 languages. Let me get started with our node. Let me bring this down. It's too high up. So node A. I think I need to first go to that folder. There we go. Node A tab, enter, and let's see. So there we go. We have, this is the input array and this is the output. For an array that is empty, we're just going to print that. One item doesn't make sense if you reverse it or not. And then here we can see we have second and first, and then 1, 2, 3, 2, 2, 1. And here is the rest of them. So we have undefined, null, true, hello, and 1. Right. The JavaScript version is done. Let's jump into the TypeScript version. So inside of the TypeScript, what we're going to do is we're going to try to solve this manually, much like with our previous challenges. That's what we try to do. So nonetheless, whatever we want to do, we need to have our reverse array method, function. And this is going to accept an array of any type, right? So it could have numbers, as you saw, it could have numbers and strings or like other data types as well. So I could say that this is a generic array with type T, and type T could be anything. So this is going to accept an array, and I need to type annotate an array, right? So how do I do it? I pass in square brackets. Let me zoom this in, collapse that. So this is an array, but what is the type of an array? That could be any type. But what does the function return? Well, the function also returns an array. What is going to be the type? Well, it's going to be a generic type because I want it to be as flexible as possible. So any type of data, we could pass it in here. And so how do we go about this? Well, if we want to go manual, and we want to select every individual item of a specific array, what kind of a language feature or what kind of a logic should we use? Well, we're going to use a for loop, right? because for loop is going to take one item of an array and it's going to implement some specific logic that we wanted, and then it's going to leave that behind. It's going to select the next item. So for this to work and to actually make sense, I need to have at least one test case here so I can actually talk about it and show you why we want to go this way. So here we have one test case that is an array that accepts 5 items, right? 1, 2, 3, 4, 5. Now the number of items, it could be variable, right? It could be 5, 4, 1, 2, whatever. So we want to make sure that this for loop is going to be as general as possible. So before moving forward and talking about for loop, let's actually talk about how does this reversing work. Well, once we want to, let's say we want to reverse this array, right? There are 5 items in there. How many operations are we going to do, or how many times we want the loop run in order for all elements to change their position, for all of them to change their position? How many times our loop should run? So that's the first thing that you need to keep in mind when you're working with loops. How many iterations do you want? So here it's a little bit tricky because we don't want 5 iterations. If you iterate over this loop 5 times, you're gonna change or swap the places of the items 2 times. And if you change it 2 times, all items are gonna go back to their original place and the array is not gonna be reversed. What do I mean by this? So let's say we wanna iterate over this array 5 times because there are 5 elements, right? So the first time is I replace 1 and 5, right? So let me just write it. So the first time 1 is here and well, 1 is here, 5 is at the start. So that's here. That's the first iteration. All right, cool. The second iteration, I swap the places of 2 and 4. Okay, so 4 is here and then 2 is here. Very good. What about the third iteration? And what do I swap in the third iteration? Well, in the third iteration, I'm targeting 3. Do I swap its place with any other element? No, because that's already in the middle. So the middle elements, if you reverse an array, it's going to stay in that middle. So 3 is going to stay in its place. So how many iterations did I do up until now? I'm going to pass in 3 there. How many iterations did I do? I did 2 iterations. So I'm going to write here 2 iterations. Now, let's move forward. So in the third iteration, I don't know what to do with this 3. So I'm just going to put it in its place. That's going to be 2 iterations plus 1, right? So 3. Okay, so let's jump into the fourth time the loop runs. So in the fourth time the loop runs, I reverse the items again. So I reverse 2 and 4. Okay, so what do I end up with? Well, 4 is going to come right here and 2 is going to go right there. 2 is going to go to the start, 4 is going to come right here. So now we are in the, let me pass in another iteration. So far the loop has run 4 times, but we have 5 items. So loop should run 1 more time. So I'm going to say plus 1. And in the final iteration, what does the loop do? It is going to select 1 and it's going to move it back to its original place, which was at the start. And it's going to bring back 5 to its original place, which was at the end. So what did we end up with? We wanted to reverse array 1, 2, 3, 4, 5 to 5, 4, 3, 2, 1. But since we iterated over this 2 times more than we needed, we got the original array. Is this reversed? No. It's 1, 2, 3, 4, 5. It's not reversed. And you can see we had 2 iterations. But I want to go back and I want to talk about how many iterations did we do in order to achieve our reversing solution. How many iterations did we do? We just did 2 iterations. And do we really need these 3 iterations? No, we don't. So, okay, you might say, okay, this happens because there are 5 items. What if there are 2 items? What if there are 3 items? I'm going to come back to that. But for now, we need to wrap this up so we can move forward. So if there are 5 items, I'm going to have half of the iterations minus 1, right? So 2.5 I'm going to put it away. I'm just going to select the 2 iterations. So almost half iterations, right? Depending on the number or depending on the length of the array, I need half of that length, array's length. That's going to be the determining number for the basically for how many times our for loop is going to run. So if an array has 4 items, the loop should run for half of the length of that array. So loop should run 2 times, right? Cool. So coming back to a question you might have, that what if we have 2 items inside of an array? So half of that is how much? Is 1. So if an array has 2 items, how many times our loop should run? It should run exactly 1 time. So I'm going to bring all of our test cases and we're going to talk about it. Let me put all of them here. Okay, I'm going to get rid of this. We talked about it. So let's talk about this first and second. So this first and second, that's exactly why I've put these here, because I wanted to show you that we cover almost all edge cases. So this first and second right here. Let me just change this color. Yeah, this is better. So there are 2 items. So the length of the array is 2. What is half of 2? That's 1. That means the for loop should run 1 time. Okay. And is that going to solve the problem? Yes. Why? Because in the first iteration, first is going to go to the last and second is going to come to the front. And that's it. So if you go to the second iteration, you're going to swap their places again and you're going to end up with this original array. So you just do it once. And it doesn't matter what kind of an array it is, you do it once. What about this array? It has 6 items. So in the first iteration, 1 and 1 are going to be reversed. That's iteration 1. In the second iteration, 2 and 2 are going to be reversed. So that's iteration 2. And the third iteration, 2 and 3 are going to be reversed. Okay, and that's going to be the third iteration. Do I go to the fourth one? No, because I'm going to end up with my original array. So I had 3 iterations, so 3 times the loop ran. And how many items do I have here? I have 1, 2, 3, 4, 5, 6. Exactly half of it. So now that we know how many times our loop should run, let's just go ahead and implement it. So we're going to start from 0 because that is the convention. You could start from 1. I is going to be whatever you want to call the thing that iterates over that array or basically repeats our loop. That's I. That's going to repeat the loop. But you need to decide there is going to be a finite number of repetitions. If you go infinite, you can't do infinite. Okay? So here we have I. So we want to come up some way to just iterate half of the length of an array. Well, you need to first have the length of an array, right? And which array is that? It's this array right here. So I'm going to say this I is going to run for as long as this array dot length half of that. Okay. But what happens if array has 5 items? This is going to be 2.5, right? Okay, so do we have any other method in TypeScript or JavaScript that is going to floor that number to 2? We don't want to seal it to 3 because if we iterate over an array that has an odd number of items and we iterate one more, we might mess up the order. So we want to just floor it. So even if the array has 4 items, we're going to iterate 2 times. That's going to be enough. If the array has 5 items, still 2 iterations is going to be enough, as we just saw it, right? Right? That was the first example. So we want to floor this. How do we floor it? Well, I could just wrap it around this math module that has a function. So all of these functions are available. You could use them. Mathematical calculations. So here we have this floor. And if you hover on it, it's going to say return the greatest integer less than or equal to its numeric argument. So 2.5, if we say, okay, what is it? This is going to give us an integer. An integer doesn't have decimal points. So it's going to give us less than that, which is 2, right? So for an array that has 5 items, if we want to grab half of the length, the half of length is going to be 2. If an array has 7 items, half of the length is going to be 3. If an array has 9 items, half of the length is going to be 4.5, but we get rid of the 0.5, we just keep the 4 because that's enough, right? So all of this was just to explain to you why we do this length by 2. I believe that in these challenges, the time constraint doesn't really matter. I just want to explain everything in detail so you really understand what it is that we're doing, because these challenges are for practicing programming, for like nurturing your programming skills, and for strengthening them as well. So it doesn't matter how much time passes, we need to like really understand how something works. So you really become a programmer. Okay, so what do I want to do here? Well, I want to swap the places of the first item with the last item, and then the second item with the second item from the last, so like this. But I need to hold these values temporarily inside a variable so I can swap them and reassign them, right? So what I can do is I can hold the value of 1 inside of temporary variable and then change it with 5 and then reassign 5 with 1. That's basically what I'm going to do. So let's say, so I'm going to grab and I'm going to create a temporary variable that's going to hold in the first iteration. This is going to hold the value of the first item of the array, which is 1. So in the first iteration, this is 1. And now temp is 1. Okay, number 1. Cool. Now I select this number 1 in the next step and I change it. I assign it the value of the last item of the array. As I said, the first item and the last item are going to swap places, and then the second item and the second item from the last are going to swap places, right? So this is how it's going to go. How do I select the last item inside of an array? Well, I could say, I could select it based on its index, right? So what is going to be the index of the last item inside of an array? Well, that depends on the length of the array, right? So if an array has 5 items, the length of the array is 5. 5 minus 1. Minus 1 is going to give you the last item in an array. So, but what if the length of the array is 4? So you're going to say length minus 1, that's going to give you the last item of an array. Well, it doesn't give you like the last item, it gives you the index of the last item, but you know what I mean. So I could do length minus 1, but then I have to do like this array.length, and then I have to do array.length again. So what I can do is I can store const length. This is going to be the array.length. So this is the length of our input array. I just exported that and stored it inside of a variable. So it is easier for us to keep reusing that length. So if I say length minus 1, this is going to give me the index of the last item. But if I'm saying that, okay, this array is going to have a variable number of items, I need to pass in the index in there as well. And I'm going to come back to this index. So I have stored 1 inside of temp, and I changed 1 with 5 on line 7. I did that, right? So now 1 is 5, but 5 should also be 1, right? As I said, we grab 1, we store it inside of a variable, and then we say, okay, 1 is now 5. So 5 was successfully moved to the start of the array. But what about 1? 1 should move to the end of the array. So we need to reassign 5 with 1. And that's it. That's the sort of logic that we actually do when we reverse an array. And it makes sense, right? So how did we select 5? We selected using this. So I could just say this, and where is 1? 1 is inside of temp. There we go. Again, just to reiterate this, we selected 1 and we assigned it a value of 5. So 1 is no longer 1, it's 5. We did that here. And what we did next was we grabbed 5 because now we have two 5s. We have 1 5 at the start and then we have 1 5 at the end. And we assigned it a value of temp, which is the value that we stored 1 inside of. And that's it. That's the only thing you need to do. So what should we return from this function? As you can see, we have an error that says you're not returning anything from this function, basically. So we return the input array. And there we go. Let's just run this. Clear TSC, B tab, enter. There we go. Node, B tab. Make sure that it is the TypeScript file, not the JavaScript one. It is b-reverse-array. So if it is a-reverse-array, that's the JavaScript solution. And this should say node. And there we go. We got it. Let me just zoom this out. So here we have the first case. The second case, 5, 4, 3, 2, 1, 42, second first, 1, 2, 3, 2, 2, 1, undefined null, true, hello, and 1. And there we go. Very good, right? So the TypeScript version is also done. Let's jump into the Python version. And for Python version, let me just open up the file first. So for the Python one, we still have a reverse method. So we are going to just use that. I'm going to say define lowercase def reverse underscore array, or here we could just call it list since it is a list here, and this is going to accept a list, but I don't want to go with list. I'm just going to say, yeah, let's just change this to array as well. So what do we want to do here? Well, we select our input array and we reverse it. Reverse. And that's it. And then we return that. Why am I mistyping this so much? And where are our test cases? Well, I've already completed them for Python. Let me just copy paste them. The same test cases. So let's run this. Clear first. Python C tab, enter, and there we go. So we have the first one, the empty, the 42, second and first, and the rest of them. So the only difference with our test cases is that here we just have none. We don't have null and undefined. So I just passed a none. And it doesn't really matter if you pass a none or not. The idea is to have an array with as many mixed data types as possible. So that's the idea. And that's it for the Python solution. Let's jump into the Go solution. That should be easy as well, since we have a method to reverse the items of a slice. Here we're going to have our main package. That's very important. And for this one, we are going to create a function. So func reverse array. Now, this is going to accept an array that could have any types of items. And in Go, the way you implement this is you could use either an interface, which is an older syntax. If you have watched the previous two challenges, in one of them, I used the any type, which is exactly the any type that we have in TypeScript. And then in the other challenge, which was, I think, challenge 12, we used the interface type. And the interface type basically did the same thing. But the any type was a newer syntax. It's a newer syntax. Interface is an older one. So here, what we're going to do is we're going to use the any type. This basically means this function has the ability to accept an array that has any type of items inside of it. So here what we are going to do is we're going to basically select a method which is called reverse. Now this method is not available like this. As you can see, there is an error. It's available on a package that is called slices. So let me import the package as well, and here we pass in our array, and this is going to change the order in place, and then we return it. And for our test cases, here are all of them. So we need to import this FMT as well. I just imported that. There we go. So we imported the formatting library as well as the slices package or library. There we go. Let's run this. The ones that have some sort of a method, they're easier, right? Clear, go run the tab, enter, wait a few seconds. And there we go. So we got 5, 4, 3, 2, 1. We don't have any commas because that's how basically Go produces an array for us. And there seems to be 1.1 here. I'm just going to get rid of that, save this, run this again, and there we go. So 5, 4, 3, 2, 1, an empty array right here. We have 42, second and first. The other array beneath it, and then we have this nil. So nil is going to be shown like this. Very good. And one more thing that you need to keep in mind is whenever you use the any type, you need to type annotate your input array with that as well. But then once you type annotate your input array, the array, whatever surrounds the array, is not going to be brackets. It's going to be curly braces, because that's the syntax of the any type. That's the only thing you need to keep in mind. Aside from it, you're good to go. So let's jump into the final language. So what do we want to do here? Well, the difficulty comes once we talk about a function that could accept an array that will have several different data types. So if you have a function that only accepts an array that has numbers, that's easy to implement in Rust. It's almost like the other languages. That much easy, right? But if you have a function that accepts an array that could have a number and a string, or an array that could have just numbers, and then the same function should accept an array that could have strings, that's difficult. You need to do a lot of preparation in order for that function, or if you want to implement a macro, for that macro to be able to handle all of that. So what I want to do is, first I want to prepare you for all of that, because that's very important, and it is going to look like the previous two challenges that we have done, but there are going to be some differences as well, because I don't want the code to be copy paste of previous lessons. So the first thing that I'm going to do is I am going to define an enum. This enum is going to be called an element. That's going to be the name. But this enum, it requires some prerequisites. The first prerequisite that it's going to require is going to be an attribute. It is actually going to require two attributes. And attributes in Rust, let me just zoom this in, they start with a number sign. So I'm going to write here derive. And what is it that we want to do within this attribute? So derive basically means that we want to tell the Rust compiler to automatically generate implementations for us. All right. Now, what sort of implementations do we want, or what sort of traits do we want? We want one trait that is going to be able to show or basically prettify our code inside of the debug. And we are going to grab another one, which is called clone. Clone is for creating deep copies of data with the clone method. And I'm going to come back to this once we actually start using this. All right. So that's going to be the first feature, the first attribute. The second one is that we want to basically suppress some warnings if our code is defined, but we do not use our code. So for that, we're going to define another feature. Syntax is the same. So we have number sign, square brackets. So we want to say allow dead underscore code. So these are the two features that I wanted to define. Now, once we talk about this, this enum, what is it that this enum is going to do? Well, the job of this enum is to give our function the power and the ability to accept an array that could have several different data types. So you can think of this enum as a utility built, like the one Batman has, for our function. So our function has some extra powers, right? So what kind of a power do we want to give to our function? Well, we want to give the power to our function to be able to accept a number. Let's start simple. Type of that is going to be 32. So that's a number. That's the first power that I want to give to my function. The second one that I want to give is to be able to accept a string, right? And that's going to, I'm going to call it text. The type of this is going to be str, but then what we are going to do is we are going to make sure that this is going to be a static lifetime. And that basically means that our string data, since we are in Rust and typically we talk about this stuff once we talk about the Rust language, there is just a lot of jargon that is going to be thrown around, but I want to explain all of them, what the idea behind all of these is. So once I say that I want to have a static lifetime, this means our data or our string that is going to live for the entire program duration. So you need to denote this, you need to specify this. So the way we specify it using this static. So I'm just going to write static here. All right. So this is a string that is going to be available for the entirety of the program. That's the second power. What is the third one? So what is the third ability that my function should have? Well, the third ability is for it to accept some sort of a Boolean value. That's something that we know from the last test case in JavaScript, TypeScript, Python, Go. So we have a number in there, we have a string in there, we have some sort of a Boolean value, we have some sort of an undefined or null or some meaningless value there as well. So we need to have all of this functionality implemented on our function. And the last one is going to be none. And that is going to be it. So none is going to be a unit variant. It basically is the same thing as we have like null or undefined in JavaScript. It represents nothing. So these are the powers that I gave to my function. But before giving these powers to the function, we need to actually do some conversions. So we have an array of some type, and then the array has some types, some type of elements inside of it. We need to convert those items to their specific counterpart. So if I have a number, I need to make sure that it's converted to an i32 type. My string should be a static one, the bool should be bool, and the none should be none. I need to do these conversions. And this is all happening before data goes to my function. All right. So we're just preparing and dressing the input of the function. We're not yet talking about what the function produces. This is all the input. This is all going to the input. So we have some sort of implementations in Rust. These are called trait implementations. And the job of these is, in this specific scenario, to select any item from the input, and it's going to select them by iteration, but we do not have the iteration code block yet. I'm going to come to it. We're going to get there. But for now, the job of this is if it sees a number, it needs to make sure that the type of it is i32. So that's going to be one implementation. The other one is going to be for string. If it sees a string, it needs to make sure that it is a static string, right? So I'm going to show you how this works. Now, this implementation selects something, so from, and it converts it to something which means for. So from something, convert for something. What do we convert it for? We convert it for element, because element is what is going to basically decorate our function, which is not technically correct, but it gives our functions more abilities. So what is this going to accept? Well, I have 4 things inside of my enum. I have a number, a text, a bool, and none. So how many implementations can I have? Well, I could have 4 implementations, and I'm going to go one by one. So the first implementation is going to be for number. the type of which is going to be i32. So what do I want to do in here? Well, I have this from function, which I'm going to use wherever I have my iteration logic, wherever I have my looping logic. I'm going to invoke this function there, but here I'm going to define the function. So this function is going to accept a num. The type of that is going to be i32. You need to make sure all these types match, and we're going to convert it for the element, which you could call self as well. And so now, if you want to convert a number to an i32, which method should I use? Which associate with which? Oh, come on. Which associative method of this element should I use? Should I use number, text, bool, or not? Well, I'm going to use number. Oh boy, there we go. And I basically pass in num. That's it. So we implemented the number. Let's go ahead and let's implement the text one. So we do these separate from each other. We select from, which is going to be something that's going to come to our function as our input array, and then we convert it for the element. So what is going to be this type? Well, we say that we accept this type. There we go. Let me just put it right here. So it's a lifetime static string. And which method it is that we want to use here? Well, first let's create the function definition. So we select some sort of a text that is going to have this type. We convert it for element. Which associative method of the element should I use? Well, I'm going to use the text one, right? And I'm going to pass in our text here. Very good so far, right? And now let's go ahead and let's implement it for Boolean. IMPL from, what do we accept? We accept a Boolean value. What do we convert it for? We convert it for an element, for the enum element. So the same thing. We have our function definition. Because we are going to call this function, we need to define it first in order to call it. I could call the whatever the function accepts as a value. The type of that is going to be bool. And which method from this enum should I accept? Should I select? I'm going to select the bool, and I'm going to pass in the value. So far, very good. And the final implementation is going to be for nothing, right? So how do you specify nothing? Well, we here, if you just pass in empty parentheses, this is going to represent no meaningful, basically value, like null or undefined. So we're going to convert it for element and function definition. So how do you represent a no meaningful value? We could just pass in an underscore, the type of which is going to be this. And we convert it for self. Oh, I should go outside of the function. Self, which method or which property of the element should I use? I'm going to select the none. Very good. So our implementations are completed. Next up, we are still again talking about what the function accepts. So I'm going to complete what the function accepts. Then we're going to talk about what the function produces. That's something else. And then we need to dress that up as well. Okay, so here, the way I'm going to go about this is I'm going to create a custom macro, and custom macro requires the syntax macro rules. So there are going to be, you could have as many rules or test cases as, I shouldn't call them test cases because that's our printing lines or print statements. You could have as many rules within this macro as possible, right? But we're going to talk about how many we actually want to have here. So the first thing is you need to write macro rules. The second thing is you need to specify a name for your macro. This is a custom macro. And the way we actually invoke this is going to be a lot similar to invoking a simple function. So this macro is going to handle a couple of edge cases for us, a couple of cases. The first case that I want this to handle is what if function accepts or receives an empty array? And now the syntax for a macro is like this. So let me go back. Let me pass in another pair and just get rid of that as well. So this is the syntax for a macro rule. Here you pass in the expression, all right, or the pattern. And based on this, you repeat something inside of this double curly braces, right? So you could write logic here. That's going to be our next rule. But in the first rule, what I want to say is, what if the array is empty? So if the array is empty, what do we want to do? Well, we just want to generate a new vector, a new array. So I'm going to say vec. I'm going to select my element. All right. And I'm going to generate a new one, a new vector. And that's it. So why do we want to generate a new one? Because a new vector is an empty vector. So remember, if we receive an empty array, we pass in, we basically print an empty array. So that's the first one. Let me terminate this as well. And for the second rule, what we want to do is we want to iterate over the items within our array. Because at this point, the array contains something. If it doesn't contain anything, that's going to be handled by the first rule. And now how do we handle the second case? Well, first off, let's just add the syntax, double curly braces here. All right. So in here, I know that I'm going to have an array. So I just open up curly braces. And when I talk about an array, I want to select items from that array, however many items there are. So I need to have some sort of a repetition syntax. And the repetition syntax, once you talk about macros and custom macros, looks like this. So you have a $sign and a pair of parentheses. That's going to be your repetition syntax. So what this does is it's going to repeat whatever is inside of it 0 or more times. All right. So that's our repetition syntax. Now, we say that once we talk about like for loops in JavaScript or in TypeScript, there is something inside of the for loop that goes inside of the array, which we call I, and it basically iterates or repeats that for loop. We need to have that sort of an expression here as well. And we could call it element or LMELEM. And then this should be a valid Rust expression. So it should be either a number or it should be either a string. That's why we say EXPR. And we need to specify what is the type of this. What is this element? This element or this elem, this is actually a temporary meta variable that is going to hold the values from our input array. Much like I was holding the values temporarily for as long as that loop ran. And once the loop finished, I didn't hold anything. So here we need to specify this, that this is a temporary variable, and we specify it again using a $sign. And finally, we need to specify that after each item, we need to have commas as well. So I'm going to pass in comma and I'm going to pass in the star. This is basically going to say that we want our items to be comma separated 0 or more times. All right. So this is, you could think of this as the initial point of our for loop. That's that. So here, this is the repetition syntax of our for loop, right? Now, what do we want to do once this loop actually iterates over our items? Well, in each iteration, we want to create an array, and in each iteration, we want to populate that array. So let's create it. I'm going to call this let elements, and we're going to create. So how do we create an array or a vector in Rust? Well, in a macro, we could use the vec macro. This is going to generate that for us. And the repetition syntax is going to look a lot like what we did above. So we have our $sign. Where is my $sign? So here is, there we go. And in each repetition, remember, once we populate the new array, we need to make sure that those elements are converted. Remember, I said we are going to invoke our implementations, right? And what was the name of these implementations? The name of the function that we want to invoke, it's called from. So I have this element. On the element, I'm going to call that trait implementation. And to that trait implementation, I'm going to pass in my elem. So how does this flow? This elem is going to be passed to this from function. This from function is going to be invoked with this. So this elem is going to come to here. From here, what we do is we basically come to the definition of this function and we change the type to none. So depending on the type, we invoke one specific implementation in one specific iteration. So if the type of the element is number, we invoke this implementation. We convert it to number. So this enum has converted that, and then we basically call the function with it. Now, the way that I'm going to go about this is right here, you could say, okay, our work is done. And in here, I could call reverse underscore array function, and I could pass in elements inside of there. So what I could do is I could specify an external function, right? Outside of this macro rule, so define it and then call it here. That's what I did with the previous challenges as well, for the most part. But in here, I don't want to define another function. I just want to have this reverse array macro to act as a function for me as well. So what do I mean by this? Well, I am going to implement all of the logic within the second rule. So we don't have to create another function. All right, so I'm going to create a new variable and I'm going to call it result. This is going to be a mutable array because this is going to be changing for us. And that's going to be a new array for us. Very good. Let me terminate this one as well and terminate. Well, I need to complete this first before terminating. We need to add our commas as well. Very good. So this result is going to create a new vector for us and it's going to populate it with all of the items. Now, if you pay attention, so far we have just implemented the iteration logic. We haven't actually reversed anything. So how do we actually try to do this? Well, we have all of, as I said, we have all of our elements. We have the vector along with the elements inside of this elements variable. And then we created a new vector. So what we do is we populate this new vector with the items from this elements vector, but we make sure that the last item of the elements vector is the first item of the result. And in this way, result is gonna have the items in the reverse order from the elements vector. How do we do this? Well, so you need to keep in mind, we select the last item of the elements and we start from the end of the elements vector, then we move forward. We move basically backwards. So if the input array is 1, 2, 3, 4, 5, that's going to be the elements. What is the last item? 5. So we start with 5, and that's going to be the first item that we pass into result. And in this way, result is going to have the items in the reverse order, the same items, just the order is reverse. So if we do this, the logic is going to be a little bit different than the one that we did in TypeScript, which was manual as well. So for TypeScript, we iterated for half of the length, because if we did that more, if we iterated more, we would have just basically ordered the elements that we swapped in the first place. So we would have ended up with elements exactly like our original array. But now here, since we generate a new array, we populate it with all the elements that we have in our initial array. We need to iterate over the entire length of our array. All right, so I'm going to say for I in, how do I iterate over the entire length? Well, first I need to grab the indices, however many indices there are, that's going to be specified. That's going to specify how many times I'm going to iterate. So I'm going to say 0.point elements dot length. So 0 point or dot elements dot length. This is going to basically loop backwards over our elements array, and it's going to start again. Backwards is very important. So it's going to start from 5. It's going to put it. Well, we didn't actually write the appending functionality, but that's what it's going to do. So it's going to select 5, and then it's going to select 4, then it's going to select 3, then 2, then 1. So it's going to start backwards. And then we are going to call our reverse method right here. So 0 point elements, the length, that's going to give us the number of indices that we want. But keep in mind, it's going to ignore the last index or the last item. Why? Because we start from 0. It's exactly like the one that we had in JavaScript or TypeScript. So we say for I is 0, we iterate for as long as 1 less than the length of the array, because if you go the entire length, then that's going to be 1 item out of bound, because indices are 1 less than the 1. So indices start from 0, but lengths start from 1. 1 is 1 more than 0, right? So that's why we exclude the last. So if any array has 5 elements, the length of it is 5, but what is the highest index? It's 5 minus 1, 1 less, which is 4. So it's 0, 1, 2, 3, 4, because indices start from 0. And then we reverse it, and once we reverse that, what do? We select our result and we push new elements to this vector. Well, how do we push it? Well, we need to specify what element that is. So I'm going to select my elements and I'm going to pass in the loop agent, and I'm going to call the clone method, which is going to do a deep copy. This is needed because the element it implements clone for us. So we did that inside of an attribute, and therefore we need to make sure that we pass in a deep copy of any individual item. We push it to our results array. And this should be it for whatever it is that the function accepts. This macro accepts, it generates, but the generating and the printing part is still remaining. We need to actually go ahead and do that as well. So that's going to be, and then we basically return our result. Let me hit enter here, just there. We still need to have to close this one. Let's save this. So this is all what the function or what the input logic is going to be. And now let's go ahead and let's create the output. And what we want to do is basically we want to make sure that whatever this element enum displays, that is going to be displayed in a display trait. So let's go ahead and let's try to implement it. That's going to make more sense why we needed what it is that we are actually trying to do. So this is going to be a trait implementation. As I said, this solution is going to be a little bit different than the previous ones. So we have this display, and now we are basically talking about what the function produces. All right. So we have this display, we want to change it, or we want to basically convert it to this element. Let's go ahead. So how do we do this? Well, we have this fmt function that we're going to call. What is this fmt going to accept? Well, this could accept a self. So I'm going to pass in a reference to the self. And this basically means that it borrows the element. It doesn't take any ownership. Self in these trait implementations, they're referred to whatever you want to convert for. So we want to convert for element. The self refers to element. The first thing is we need to make sure that we don't take ownership. We just display some stuff. Second thing is going to be if this is going to be a mutable reference to the formatter, where we actually print our formatted string. All right. So this basically refers to our print line. So this is going to be mutable, right? Mutable reference, and it is going to come from std fmt formatter. There we go. And let me pass in the underscore there as well. Now here we need to handle an edge case as well, because if formatting fails, we need to have a safeguard. So on the std, I have an fmt. On there, I have this result. So this is going to return OK on success or error on failure. There we go. So how do we actually do this? We're going to have a pattern matching. And the pattern matching is going to refer to self, to the element enum itself, and how many basically members or variants we had inside of the element. Let's select all of them. So I had one which was number, right? I had, let me just copy paste it. I had another one which was text. I had another one which was bool, and finally I have this none. Now, the reason that I'm doing all of this is, what if I want to print numbers? How am I going to show numbers inside of the console? How am I going to show text inside of the console? What about booleans? What about nones? So I need to specify all of that. These are basically some extra things that I like to do because I want to overcomplicate simple things. So if we have number that is going to be like, you could call it n, then what we can do is we are going to use some sort of a macro here, and I'm going to use the write macro, and that's going to format our n into our formatter, right? So how does it format something into a formatter? Let's pass in our formatter, let's pass in the placeholder, and let's pass in the number. So it's going to format this into our formatter. Pass in a comma. So this is going to be the pattern that we're going to go forward. We have this text. What is the text going to accept? It's going to be, you could call it an S, which is going to be a string. And this write is going to format that S into the formatter. What about bool? We could call it B for short, and then it's going to convert B into F. And final one, we don't have anything, just pass in that. Since there is nothing, we just have our none here. Very good. So we have all of our test cases here. Let me just take a look at this. So we created a pattern matching. You could think of this pattern matching like switch statements that we have inside of JavaScript. So if or switch, then if case is number, we do this. Case text, we do this. Case bool, we do this. And finally none, we do that. All right. So now that we have created all of this, let's actually try to create a function that is going to implement this for us. So I'm going to create a function that's going to be print elements. And then this is going to accept elements. And the type of that is going to be a slice of an element enum. But what that is going to produce is, as we specified, it's going to be string. All right. So we select our elements, we convert them to an iterator so we can iterate over it. And then once we can iterate over it, we're gonna convert everything to an owned string here. Now, whatever I'm about to write inside of this map, that's called a closure function. You could think of it like an anonymous arrow function. This is an anonymous function. So our function, anonymous function or closure function, is going to accept a parameter called x, and it's going to grab x and it's going to convert it to an owned string. So here we're going to say to_string. Very good. And then we collect everything into a vector. So let me just type annotate this and pass it there. Are we really worried about what the items are? No, so I'm just going to pass in an underscore. We just want to convert everything. And there we go. That's going to create a vector for us. And what do we want to do at the end? Well, we want to join it with a comma or at the comma. So let's just pass in the comma here as well. So I tried to do that all on one line. What else do we want to do? The last thing that I need to do is we just need to create our main function. So this is the main function here. Now, as I said, the formatter is going to be the write. This write is going to format this f into our print line, remember? So we're going to say print line macro, and the first thing that it is going to do is, and let me just copy paste this. It's going to say test cases. All right. And then we have the second print line. I'm going to select the string and I'm going to basically write the function invocation, right? So what do we do? Let me just go back. What do we do for the function invocation? Well, remember, we have this print elements function that we said, okay, that's going to prettify the output of our array, output of our macro, basically. So where is our macro? Our macro, now keep in mind, this print element, or should I call it elements? Yeah, I should call it print elements. This is going to accept a slice, right? So there we go. And then let's call our macro reverse array. Now this reverse array is a macro, so you need to pass in that exclamation mark. And then where is your array? So it's 1, 2, 3, 4, 5. That's the first case. And there we go. So what I could do is I could just call this one and let's see if there are any errors. So if this works, all of the other ones are going to work as well. Zoom this out a little bit. So we have Rust CE tab, hit enter. We seem to have a few errors. So let's go to the top. What is it expecting? Expected parameter name. This is on line 53. Let's go to line 53 at self. So here it expects a parameter name, fmt self, parameter name, found $. Oh, sorry. This should be a reference. This shouldn't be a, this should be this one, a reference, right? Not a $. Okay, that part is done. At mat, yep, that's this should be also reference. Okay, just typos. And where else? Oh, all of these are references. And this is also $. Should not be, it should be ampersand. Expected. I thought I added that. Apparently I didn't. Here, let me get rid of this one. There's just one. Or let's add this, get rid of one from here. Yeah, much better. Very good. What else? I should terminate this, or I don't have to. Found expected, found print line. Print, oh, here. There we go. Save this. Let's clear everything out. We still have a few errors. Let's just see. Oh, why so many typos? So this is on line 53. Let's go to, there should be double colon. Save that. Let me run this again. Okay. Formatter only if in trait may use parentheses. Formatter. Let me take a look at. This is syntax. Again, syntax. Just some syntactical problems. So that one is done. This is, all of this is that formatter. Okay, so let's run this again. All right, now what do we, you can see it says cannot find trait from in the scope. Help a trait similar name exists from bool. From implementation, similar trait name defined here. Do we have the trait name? Are the trait names similar? Oh, this should be uppercase. And yep, should be good to go. There we go. Very good. It compiled, and let's run it. So we have 5, 4, 3, 2, 1. So we just reverse that. That is awesome. So we joined it at comma, right? And I could add a space after the comma, so they're too congested. Just add a space. So now that we know that it works, let's actually bring the other test cases. As I said, I'm just going to copy paste the other ones. So we have this. Let me go back. We have the other one right here. That's the 42. After that, we have test case 4, where we just have strings. We need to have all of these so we know that our macro works properly. 5. And finally, here is our final test case. Take a look at this. So we just have an empty pair of parentheses there. Save this. Let's run it. There we go, compiled. Run that again, and there we go. So we got 5, 4, 3, 2, 1, empty, 42. Second and first, 1, 2, 2, 2, 2, 1, 2, 3, 2, 2, 1, none. See, so if you pass in just none, you're going to get none. True, hello, and 1. The only thing is that these are all strings, which doesn't really matter. We could convert it. We have talked about these conversions in our previous challenges. I just wanted this one to be a little bit different. So you have like all of these tools in your toolkit. So with this one, challenge number 13, was it 13? Yes, 13 has come to an end. And see you in challenge number 14.